Hi, I'm Mrs. McTaggart. In this video today we're going to be looking at quadratic graphs, and the ones we're going to be looking at today are the ones in the completed the square form, and we're going to practice being given the equation and writing down the turning point, and vice versa. I'm going to give you a picture with only the turning point and we're going to write down the equation. So that is the aim for this lesson. Okay, so this is a really important kind of slide here. It kind of summarises the 4 different styles of movements in the graph. Graphs that move up and down, left and right, and then a wee bit of both. So this one here that I'm just pointing to here in yellow, this is our most basic quadratic graph, and you should have seen this already. This is just a graph of y equals x squared. If we now look at this one, and let's call this graph 2, you can clearly see that all that's happened to that graph is it's been moved up the way. Now the same with straight line, when you move it up, all that happens, the same with the sine and cos graph, all that happens is when you move it up, there becomes a plus c at the end of it. Similarly, if you'd moved it down, it would have a minus c, alright, whereas c is just a number. This third graph down here now, so let's call this one graph 3, you can see that the graph is moved to the right. And when it moves to the right, the change to the equation is there suddenly becomes a little number in a bracket there. Can you see that? So it says minus b. Now notice, this is really important. My graph has moved right. It has moved in the positive direction of your coordinates, but there's a minus in the bracket. And the wee thing I always stress to pupils is that it's always the opposite of what you think. And I've written that down here, right? That the line movement is always the opposite of the sign. So if it's moved in the positive direction, it's a negative that goes in the bracket. Similarly, even if I'd moved this graph over this way, that would have had an x plus b all squared in the bracket, because it is now moved in the negative direction, so it's a plus in the bracket. And the reason it's the opposite of what you think is if you solved each of those wee brackets equal to 0, the minus would come over and become positive, and you get this value of positive b down here. So opposite of what you think, and you should have maybe seen that if you've already seen the graphs of sine and cos already. And then this last one here, this is probably the most important one, where we're bringing it all together. On this one, you'll notice the graph has been moved a bit to the left and down. So this one here has the equation of x plus b, because it's gone in the negative direction, so it's got a plus, and then it's got a minus c because it's been moved down. And what we're going to do is we're going to have to, from the equation, write down the turning point. And we're going to have to, in reverse, I'm going to give you pictures and we're going to write down simply the equation. So let's summarise what we've come. So this is our most important graph here, this one. Alright, and I'm going to summarise that again in the next slide. So that equation there can be written as plus and minus b in the middle, and it can be plus and minus c at the end. And depending on the movement, we'll decide that sign. This is a general equation of any quadratic graph, and you might recognise that looks a bit like what you get when you complete the square, okay? And the reason we complete the square is so that you can simply read off the coordinate of the turning point. Now your turning point is BC, so this bit here, right? So whatever these numbers are for B and C, they are going to get you your turning point. And just remember, the B is opposite of what's in the bracket. So if it says minus 2 in the bracket, you write down positive 2. And then the equation of the line of symmetry is always x equals b, whatever your turning point is. Because on a quadratic, if this was your turning point, BC, your line of symmetry would be running through the x coordinate. So the line of symmetry is x equals b. Let's look at this in action now. So for each of these, we're going to write down the turning point and the equation of the line of symmetry. So I'm just going to write down here at the bottom what the general equation was again. So it was x plus or minus b all squared plus or minus c, and our turning point was BC. So in this one, this is your b, this is your c. This is your b, this is your c, this is your b, this is your c. So on this first one, your turning point, remember I said it's the opposite of what it says in the bracket. Plus 4 means it has gone left. So that would be minus 4, positive 1 for that turning point. The turning point for the second one, it says minus 2. So that one means it's going to the positive direction. So it's positive 2, negative 5. And the third one, the turning point is, it says positive 1. So again, that's going, I've written that the wrong way. That means it is going to the negative direction. So turning point is negative 1. And then positive 7 on the end. That's the turning points. Now I'm just going to quickly look at the natures. Now the nature is asking you whether it's a minimum or whether it's a maximum. And remember, a minimum turning point is when you've got positive x squared, and a maximum is when you've got negative x squared. Now, the only one that's got a negative in front of it is this one here. Like, notice that there's a wee -1 in front of that one. So that is the only one that has a maximum turning point. So whatever's in front of the bracket decides. So there's nothing in front of the brackets for A and B, so they are both minimum turning points. And that would be the nature, okay? So they're both minimums. And this last one, because there's a minus in front, that means that is a maximum. That is a sad face shape. And the equation of line of symmetry is just always x equals whatever your x coordinate is. So the line of symmetry is x equals -4 for the first one. For the second one, it's x equals +2. And for the third one, it's x equals -1. Okay, and it's really important that you can do that because it's actually only a couple of marks, but if you can do it, it's some of the easiest marks in the whole paper. Right, lastly, we have the scenario where we have a picture and now we have to write the equation. So remember, the general equation is y equals x plus or minus b all squared plus or minus c. So your turning point is your BC. So I'm just going to keep writing that next to all. So your turning point is your BC. So this first one is y equals x. Remember, it's +4, so we put -4 all squared, and then -3 means down 3. That's the first one done. The second one is y equals x. Now your coordinate is -2, so we put in the opposite, we put in +2 all squared, and then it's gone up 4, so +4. And the last one, it's got +3 for the turning point, so we put in the opposite, we put in -3 all squared plus 5. And that's it. Hope you followed this, and good luck.